have this go to certain playlists. It'll make things so much easier. So I'm going to do my shapes. I showed very quickly some different techniques for different shapes. Some of you have diamonds, some triangles, some circles, okay? I have ellipses. So I'm going to go to the circle tool, choose the ellipse option. For many of you, not all, but many of you, when you place the center of your thing, it'll actually be on this line. It's not the case if you do a triangle, okay? That's not the case if you do a triangle. But for most of the shapes, it will be. And I'm going to use the calipers, and I'm going to make some measurements. Now, one of the things that you're going to find is that what's easiest to dimension in the software and what's easiest to measure with the calipers are not the same. For example, the easiest thing to dimension would be the center of my ellipse. Okay? Good luck measuring with calipers where that is, right? So what I'm going to do is I'm just going to measure how close this edge over here is of my ellipse. Sound good? Yeah? I'm going to measure how close that is. And when I do that, you know, I get a number. So it's about 2. So what I want to do is I want to dimension from this edge over here, and I'll even kind of tilt it a little bit so you can see what I'm clicking on. This edge right here to kind of like the edge of my ellipse. Now, there's a few issues with this. One, this edge is not actually part of the sketch. How do you get it into the sketch? We talked about this with the thing right before this. How do you, if you have features or items part of a different sketch, how do you get them into the current sketch you're working with?
I don't know what it's called, but not square thing.
It's a square thing, so it's called projecting. So right here, there is this project button. Yes, yeah, yeah? So if you click on that, then you could, for example, click on this edge. Or you could click on this face and it'll project like the entire perimeter. Okay, you do you. Basically, once you click that button, whatever you're hovering over, if you see orange, that's what's going to get projected. I just need to project this line or this point, okay? I don't need, you know, everything projected. So I'm going to project that line. And you'll notice now that if I were to try and dimension that line, I can actually click here now. It's lighting up orange. Okay, I know it doesn't look any different, but I actually did project that. We understand? Yes, yeah, yeah. Okay. Now, I still have an issue. I can't, like, click on. Let me draw my lips again. I still have an issue, and that issue is I can't, like, dimension to this point right here unless I put a point there. Okay? So we fixed this, or I showed you this earlier with a different thing we're doing. You can place points. You can place points. And if you do that, the software will typically have an auto snap. It might be hard for you to see, but there is actually an orange square right there. It does recognize things like the vertices of the ellipse or the midpoints of the sides of rectangles, or really just the midpoints of lines in general. So I place a point there. Do we see the white dot now? Yes, yeah. And then I can go over here and I can place a point right there, recognizing that that's the midpoint of that edge. So there's different options here. You can use projecting, you can place points on stuff. But now that I have these 2 points, okay, I can actually dimension that distance. That is a very easy dimension to measure. So you need to be creative with your software skills, because sometimes what would be easiest in the software is not realistic. Yeah.
Are we gonna make like clips on the side?
Yeah. We are. Maybe not.
Those are gonna be like.
Maybe not dutifully, but we will make them.
Okay.
Everything we've done so far is to show you something you haven't really necessarily done yet, right? I'm showing you projections and strengths and symmetries and things.
Next time. Snack time and nap time. Don't do anything.
Now I have made my ellipse. Okay? I've made my ellipse. Now, the ellipse on the other side is a mirror image, basically, right? Yeah? So I could redo it all. Same numbers, same dimensions, same strategy. There is actually a mirror tool. So right here, there's actually this mirror tool. And this allows you to do everything all fancy once and then just mirror it to duplicate it so you have symmetry. You can mirror things in a sketch, or you can mirror features. And which one you do, honestly, it kind of just depends. Like with fillets, I think that a lot of times it was easier to do the fillet as a feature rather than within the sketch. You'll find with mirroring, sometimes it's easier to do it in the sketch, and sometimes it's easier to do it as a feature. So I'm going to click this. And when I clicked on it, it said select a mirror line. So the mirror line would be the thing that I would mirror this about. And the obvious choice, if I line it front, would be this plane right here. Right? That would be the obvious mirror line. So I click on that. And then it says select entities to be mirrored. I just clicked on my oval. And then I hit escape to get out of that. I'll show that one more time. So whatever you have over here, whatever shape you have, if you get it done correctly on one side, it's trivial to get mirror to the other side. You click on the mirror tool right here. You says select a mirror line, so the obvious choice would be this plane. And then select entities to be mirrored. I'm just going to go with my shape. Easy, trivial. So I did all this work to do the left side, and I had to do basically no work to mirror it. Okay? Saves you a lot of time. And don't actually change this, but if I were to change this number, say from 17.3 to 18.3, you'll notice that it changed this over here as well. So the nice thing now is if I have to change it, I don't only have to change it once, not twice. I like to do fillets as features rather than within my sketch. I like to mirror things in my sketch if I can, rather than mirroring the feature. But it depends on what I'm doing. If there's a bunch of features like an extrusion and a fillet and another extrusion and maybe something else, I'll mirror all those features at the same time. But if I'm just like trying to mirror something, then I would rather just do it in one extrusion than do like two extrusions or something. We have questions. We have questions. Okay. So I'm going to extrude this now. So these would be the elliptical holes.
Yeah, we can put the paper.
And then I will actually extrude. Make sure you choose remove. We're doing a cutout. I didn't really pay attention how deep they are. They should do that. 12.8. We'll go with that. Sounds like a good number. And we are pretty much done with this part. You guys want to do the clips?
Yeah. That sounds like a lot of work. Would they be hard?
It depends on how much effort you want to put into doing them.
Oh, you can't like.
You
add
definitely
massive
could
amounts
put
of
a
work.
lot in if you want to.
Like you could make a basic clip, or you could like really try to replicate that fully.
Does the clip matter?
I think we're
I
chilling.
mean, it matters in the real world, but you know, we're not gonna 3D print this, right?
Oh, then no, we're not. I don't think we should do.
So I'm kind of inclined to skip them.
We're not printing our cars.
That we're not printing it
Why would we print when we have real cars?
because they're very cooler in 3D printed.
The purpose of these is to learn how to CAD, not to make them again.
But if any of them breaks, we can just have backups. We print these.
That can.
Wait,
I'll
no,
tell you what,
Never mind. Let's not do that. Let's not do that. Skip the clip.
you want to come back and do clips at your own at some point in the future, you can.
Yeah.
But
Yay.
I'm gonna say that I've shown you mirroring, I've shown you some symmetry techniques, I've shown you some constraints. You know, I've shown you some proper like labeling things and using planes appropriately and renaming stuff the right way. Like I've shown you, I think, what I wanted to show you of this. Are we good so far?
Mhm.
Yes, yeah.
Are we good?
Okay. So I'm gonna say that for this at least, we're good.
It's gonna be done.
Questions? We're good?
Why they extrude that?
All right. What I would like for you to do, you're going to need to take the people out of your car. The next thing we're going to do are these plates that the people fit in. So I don't really know what you want to call it. I was thinking like the passenger base or something like that. Passenger holder or something like that. I'm gonna call it the passenger base. Most of you have 4 holes of 4 different shapes, but we all have the same shapes. I want to say one of the cars only has 2 holes, the sports car, the purple one. Or the
No,
orange
that's
one.
the
The orange one. Who has the orange one? Jordan, you have the orange one? I think you only have 2 people. Is what it is. So I'm going to show you how to do this for the 4. So hopefully you learn a thing or two. So I'm going to get out of this. So I have the connector and the passenger section. Okay. What I would like for you to do, I would like for you to open up your passenger section in one tab. So if I right click on it, by the way, if you don't remember, you can always click on the on shape thing right here to go back to your documents. Okay. The on shape icon in the left corner. But I'm going to right click on passenger section. I'm going to open it in a new browser tab. The reason why I'm going to do this is there are some dimensions from this that I am going to want to consider or reference because this piece of plastic obviously has to fit in that cavity on the top of the passenger section, right? Yeah. So, at least in principle, this should be the same dimensions, right? Now, in the real world, why would it not be exactly the same dimensions?
Nothing there is.
Because they didn't get machined the same.
It has nothing to do with precision of machining. Let me ask you this. If this hole, this wooden hole, was 2 inches wide, would this plastic piece be exactly 2 inches wide, more than 2 inches wide, or less than 2 inches wide? Okay, why less?
Because you have to get it down.
It has to fit in there, right? So there's a deliberate tolerance so that it actually fits. If it was the exact same number, it's not actually going to be easy, if even possible, to slide this piece of plastic into the wood. We understand this, right? Yes, yeah. Also, are they the same material? So what happens when the temperature changes?
They like swell.
So different materials expand or contract at different rates based on temperature, right? So you definitely need to have some tolerance, okay? You may hear this term called a press fit. A press fit is where you rely literally on the tightness of the fit to hold something together. There's no adhesive or any mechanical device holding in place. It's literally just so tight that it's held in by friction. This is probably glue. Don't try and pull it out, but it's not easy to take out. Okay? Probably glue. But you can see it's a fairly tight fit on at least 2 of the sides. Okay? We're going to make this thing, so I have that open in one tab, and I'm going to make a new part, and I'm going to call it the passenger base. Good so far? Yeah. And I'm going to make a sketch on my front plane. Where am I making a sketch? Front plane. There's no reason not to use the front plane. Could, if you really wanted to, you could say, well, should we use the top plane? I mean, you could do that. I guess it's a personal thing. It doesn't really matter. I'm going to use the front plane. What's up, man? Yeah. Yeah. Good so far? You say yeah?
Yep.
Okay. Now what I'm going to start off by doing is I'm going to draw a rectangle. And I'm going to do a center point rectangle. Why do you think I'm doing a center point rectangle?
Because they're good.
Because it does it.
There's symmetry, right? There, I drew my rectangle. And this is representing the overall plate. Yeah? Yeah. So you are welcome to try and measure the width, but I mean, realistically, it's pretty much going to be the same as the width of this hole, right? Let's just make it the same. I mean, we're not actually manufacturing this with a 3D printer or something. So we're just going to assume it's the same. It's probably a little bit less, but we're just going to assume it's the same. So like, this is why you label everything. I have all these features over here, right? Which one of these features is that hole?
Sketch.
So if you picked an intelligent name, it's very obvious, right? So for me, it's a passenger cavity. So I can go into this sketch and I can see the numbers that I picked. Now, when I did this, I actually did not dimension the width. I actually made it symmetrical and just dimensioned this gap. But I can get the width if I just click on the dimension tool and I try and dimension this, okay? I will get a gray dimension. What does gray mean?
Because it's just measuring.
We're just measuring. It's actually constrained. The dimension is forced, or they use this term driven. So I can see that mine is 50.7, okay? It's a driven dimension, but it's still very useful, so I can delete that, 50.7. Right, so I can go here, and I can make my rectangle 50.7. Easy. And then I actually did dimension the height, 40.5, okay. And everything should be black. Yes, we're good? Now, so this is a fairly straightforward and easy shape. Probably could do fillets in the sketch. We'll see if it works out. I'm afraid that it will probably mess up some stuff, but we'll try it out. So you can go back to your sketch earlier and you can look. So my fillets were 4.2. So I'm going to go here and I'm going to click on the fillet tool. And I'm going to click on all four corners. 4.2. And since this was just a rectangle, I didn't have like rectangles on top of rectangles. I didn't have a bunch of weird dimensions or constraints. This worked out fairly well. Do we have questions so far?
Example.
Yeah.
How did you see the number on the bill?
Or you can click on the dimension and move it. Or you can click on the dimension like you're going to edit, and you'll see the number. Don't obviously change the number.
Sweat that out.
Wyatt, I'm pretty sure you're setting up the field next hour.
And Cole's not here.
Is he actually not here today?
No, he's at.
Imagine having FBLA.
That's what I'm saying. Imagine having to buy a suit for a school function.
Dude, I don't even own a suit anymore.
You don't?
No.
I have a suit, but you have to
That's the
eat.
teacher mentality.
Well, the thing is that kind of clothing's expensive.
Yeah.
And the reality is, if I don't have a reason to own one, I'm not gonna go.
I have a suit jacket that's just sitting in my truck right now. I've been taking it out. I have one from a wedding, and I'll probably wear it to prom the next 2 years, and then never wear it again. It's been sitting in my truck for a year. I just haven't taken it out yet. It's been sitting since.
What a guy.
Just sat in your truck. It's just been sitting in my truck.
Why do you have a single cab?
Yeah. Sit
You can
right
extrude this.
That's insane. How?
If I ever get cold, I can still that on. I'm gonna go to dinner, dude.
Really?
Yeah.
What?
There's no blazer.
It's like 1,000.
Who's point 1,000?
I mean, suits can like easily go to 1,000. Like, you probably spend 1,000.
Dude, that table that we were looking at, 30,000.
What? I would buy that though, like unironically.
I mean, if I had like, if money was not a thing, yeah, because it is nice. I'm not
It's a
gonna lie.
Great table.
A table. What, like me?
Like 10 million.
Oh, yeah, it's true.
Oh shit.
I want to see that.
It's like really nice wood.
Did you know
Oh.
that?
The inside recesses, and there's this fancy wheel that you can like attach, and you crank it, and it raises and lowers the center.
That's cool.
It's got like a nice felt finish, and then there's this magnetic rail all along the inside and outside of the edge, and you can like attach like cup holders and like
That's
dice
sick.
divots.
Did you
That's
mention the
awesome.
wheel?
That's cool.
Yes, and then you can get like a cover for it to make it like a normal table.
That's.
You can even get a bag, put the covers in, dude. It's
If I paid 30,000 for.
it's like
that,
it's
I'm
like a minimum $10,000 for just the table.
That's-
But the woods though, the type of wood.
Yeah, some of the wood though can get up to 30,000.
Get out of here.
Just the table. Just the table.
I would never use that as a normal table. That's way too expensive.
And you just come home. Oh, your kids aren't going to college anymore. Fuck that. You bought a fucking what?
I want to call this the base plate.
That's no, you didn't.
You can call it whatever you want as long as it makes sense. I extruded it just forward. And then what I'm going to do is I'm going to do a sketch on top, and I'm going to cut out those shapes. Make sense? Yes, yeah. So I'm going to sketch on top of this.
How forward did you do it? Like,
You can go to dinner, food.
You use your calipers, use the hole finder thing on the bottom. The hole
oh,
F
and then you
gauge.
measure the whole.
and you can get the height. All right, which of these shapes would be the easiest to do?
Star. Square.
Square or circle? So the square is going to be the easiest to dimension the location of, because I can take the calipers and measure like from an edge to an edge, right? So I'm going to do that. This is not going to be easy to do because you're not going to be able to get the calipers in there. But you want to try and ballpark like how far it is from each edge. It's not going to be easy. So what I'm going to do is I'm going to start off by just drawing it. Okay. I am going to do a center point rectangle, and you will see why later. But I'm just going to draw it down here. Okay. We're good? Yes, yeah, yeah. And since we're going to assume it's a square, and if you don't know, what is a thing you could do to get the dimensions of that square?
Equal. Yeah.
So this is like a really easy thing. There's a really easy way to get the dimensions of that square. You could what?
I don't think it would work. We could still.
No, there's no reason to say those are the same.
Guys.
Yeah. You can just measure the people, right? I just measure the person. So I got about 14 and a half.
Oh, there you go.
And I'll tell you, if you measure pretty accurately both sides, I mean, they're within 1/10 of a millimeter. They're pretty, it's meant to be a square. It really is. So I could dimension both sides, but what would be the smart thing to do here?
Equals.
You just do an equal constraint. Make two adjacent sides equal. So now I just need to dimension where this square is. And it's going to be a little ballparky. Not going to lie. I believe in your abilities, though. Maybe. So there's always the whole, just open up the calipers and just see what number kind of matches it. For me, I'm seeing about 2 millimeters from the short end. So I'm just going to do that. And you'll notice if I try to do that, if I try to dimension from my square to the bottom edge, it actually does work. I didn't have to project anything. So I'm going to get the bottom 2. And then the other side.
Oh, fuck, where people go.
Yeah. So what you gonna watch from here? Huh?
Maybe it's 5.5. I'm getting about 5.5. Ballpark.
Jeez, Papa Net. Oh. That was not a comfortable pop.
So I did the easy one first. We good so far? Yeah, we're good.
Yes.
Which one do you want to do next?
Circle. Sure.
Okay. Now, the circle is actually kind of easy if you've already done the square. You ready for this? When I draw my circle, see, I can line up the center of my circle with this center, right? Yeah. So that would be a horizontal constraint. Horizontal constraint. I apply a horizontal constraint to the centers of each. So now the circle is lined up with the square. You can measure the diameter of the circle by using the person. Be smart about this. Do not do this. This is not smart. Why is this not smart?
It looks dumb.
Okay, so, well, it does look dumb if you know what you're doing, but why is this not smart?
Put it all the way up there so it's like more accurate.
See, the thing is there's no way to guarantee that you're actually running through the fattest part of the circle, right, if you do this, right? So you want to have it sideways, and that way when you go around the circle, you have to be measuring the full width. There's no way not to.
Oh.
Yeah, we understand?
Intelligent.
Yeah, it is intelligent.
Wait, what?
Okay.
Well,
So
I don't know in the middle.
I think it's actually more about 14.6.
You're guaranteed to be in the middle.
This one then is also 14.6.
Just yours, idiot.
Thomas, what did you?
Fuck this little slow.
He was juggling to the corner, so it's like.
Measure up the size of it, bro.
Oh, Tulsa?
Oh shit, you're always gonna bummer.
Okay, questions?
So mean, bro.
No, I literally forgot.
Questions?
It will never happen again. I swear to everything. I swear on Parker's life. Oh.
Now, if you did that horizontal constraint so that the center of the circle is on the same line as the center of the square, when you try to move the circle, you should only be able to slide it back and forth. We see this? Yes, yeah. Now, here's the thing. There's different ways you could do this, okay? There's different ways you can do this. But I always like to make my stuff future-proofed. If I said, hey, man, we got to change the size of the circle, okay? It's not the right size. We're going to make it a little bit bigger. Probably don't want the center of the circle to move, right? We just want the circle to get bigger or smaller. Make sense? So what I want is I want the center of this circle to be the same distance as the center of this square from like edges and things of that nature. So how do I do that? Well, I will tell you that a thing that you could do is you could actually try and mirror this point here. So if you click on mirror, right? And then you click on this plane, yeah. And then you mirror this point. I now have a point that is like the same distance from the center of the base plate. Make sense? Yes, yeah. And then all I gotta do is draw my circle on top of that point. There are other techniques you could use, but I think personally that's the cleanest. All right? Now, you could use a horizontal constraint, and then you could like dimension it in one direction to lock in place. There's other things that you could do, but I think that was the cleanest solution. Are we good so far? Yeah? Maybe? Possibly? Pablo's going to be so lost. And then he's going to ask Jackson to help him, and Jackson's going to be like, bro, I wasn't here either.
Then he's gonna ask me, I'll be like, no.
He is going to ask you.
Just give like,
loser.
James, you just like tell him everything but like totally wrong.
so you make the square right, and then you can.
So draw so cool.
That's exactly how Jackson would say it, too.
Then I don't remember the last one was.
I didn't do last one.
That is exactly what Jackson would say. Guy's an absolute baller. So that is our first two shapes. Now the triangle is going to be a little bit more challenging. And the star is going to be a project in and of itself. But I'm going to show you how to do the star. And if you do what I do what I tell you, you will start to learn that if you just use some basic geometry and symmetry, strengths, even something like a star that looks complicated, it's not actually that hard. Okay? Sound good? Yeah. This class ends today at 9:53 because we had time or whatever it is.